Good afternoon, everybody, and thank you very much for being here. There are so many other interesting talks, but you chose to come over here. Oh. Okay, so I'm Shashank Daté. This is my hobby. I do it for fun and loss. Yeah, because I've lost a couple of drones and never got them back, and haven't made a dime out of them yet. For the drones to fly, though, we need a little bit of energy in this room. So here is what I want you guys to do. See the slide over here? On the count of 3, I want you all to speak as loudly, read that thing as loudly as you can so that the energy in this room goes up, okay? All right. 1, 2, 3. Thank you. All right, now if you have blessed me, because I'll show you why that blessing is required, and here pretty soon, these two should take off using my hello edu.rb file. I have to do one little thing that I forgot. Oh, give me just a sec. I have to find the IP address of these two guys. When they booted, they got a different IP. And the way I communicate with them is there is a little Wi-Fi router that I have set up over here, and my laptop is connected to them through that. So I'm going to scan for these devices, and it should take not more than a few seconds for it to detect what the IP address is of these two guys. And it's telling me that it is 102, 103, the last 3 digits that is. So I'm going to give this a shot, okay? If our energy is right, they're going to take off and land. Not exactly at the same spot, but somewhere. If they start drifting, I have drone catchers in the audience who will catch them. Okay, 1, 2. Okay, let's go. Yep. Let's see if it turns green. There you go. And that's like my teenage daughter who doesn't listen to me. She has a mind of her own. She says, no, Dad, I'm not going to land. All right, it'll land in a few seconds. It has a default 15-second wait for it to land. So that was the hello world of my drones. Thank you very much. They were much well behaved today than they have been in the past. So let's see how that goes. I have to be in the present mode now, right? Okay, cool. So these are a special class of drones called Tello drones. Tello is the type of drone that I have been programming with. These are probably the cheapest that you can find that are programmable. They're sub $150 each. The first few that I lost, I was testing how high they can fly. And then a drift of wind came through, and they were gone with the wind. Gone with the wind. So, but they're perfect for educational purposes. They introduce beginners to programming. You must have, if those of you who attended the previous talk, he mentioned the language called Logo, which was a language to teach kids how to draw turtles or diagrams using turtles on a 2D plane. This is a 3D version of that. You know, you can not only go this way, but you can go up and down. So the purpose of these drones is to teach people how to program. So there are many simpler concepts in it, but there are also some deeper constructs that, you know, more advanced programmers can get some benefit out of. The type of drones that I'm using over here are called Tello EDU type of drones. So they have progressed from SDK 1.0 to 2.0, and Tello EDU is what we saw just now. It enables us to program a swarm of drones, like you saw. I did not have the budget to buy the full EDU kit, which comes with 20 drones and costs about $5,000, but I could buy a couple and try these things on my own. And these kits, they come with official support for Python, Scratch, and Swift. I said, well, why not Ruby? You know, so I took it up to myself and a friend of mine, and we got it all working in Ruby. And my interest is in mruby, so I got it working in Ruby too. They require these concepts of network programming, concurrent programming, you know, video streaming, and stuff like that. So these are the specs. It has an Intel 14-core processor in that little thing that you saw flying. Very lightweight. They have a camera, believe it or not. They have collision detection sensors in them, and There are two flight modes available in the Tello EDU that you saw just now. There's an AP mode and a station mode. So what's AP mode? That's the access point mode that comes by default. When you pull it out of the box, you can't swarm it. You have to set it up for swarming. But the default setup is where you can have one computer control one drone, 1:1, or multiple computers controlling that one drone. But the fact remains is that a single computer can only control one drone. I have never tried the multiple computers controlling one drone, in the past, but it is possible. And then in that mode, the video streaming of the camera is on. So that's the default mode in which these drones work. But then there is the swarm mode or the station mode as they call it. And it's only available in the second version of these drones, the Tello EDU drones. And you have to set that up manually. So after you pull it out of the box, there's a little bit of configuration you have to do to get it set up in the swarm mode. And in that case, what happens is you use a router like I'm using over here to communicate with the drones from your laptop. In the previous mode, the drone itself was the access point. So it publishes its own SSID and its own password, and you have to capture it in your program and then control it that way. And that's the reason why you cannot flip between those two. So these are the two modes of communication, and these are the programming prerequisites for any language to be able to control these drones, okay? So the first requirement is that you need UDP/IP, okay? Communication should be in UDP/IP between these drones. The second requirement is that you should have some form of concurrency because you're going to send a command in one thread and receive the response in another thread, and you need to know which command does and which response match with each other. So you need some notion of concurrency is involved in there. I tried sending one after the other, like send a command and wait for the response in the same thread. Never worked because UDP/IP is fast enough, and we'll see why. And then the video streaming is kind of optional. I couldn't get it to work for Ruby or mruby, but if you really want to see the real-time video, then you have to have a real-time video processing library in your programming language that allows you to do that. So how does that work out in Ruby? In Ruby, there's a UDP socket class in standard Ruby. I use that for communication. There's fibers and threads in Ruby 2.x. And then there is Ractors. You must have heard of Ractors in other talks in 3.x. So there are so many ways of doing concurrency in Ruby. For video streaming, I was so overjoyed when I saw, I got my, I'll come to this gem a little later. I got my sequence a little flipped. Okay, so what is UDP/IP? You must have all heard of TCP/IP. UDP/IP is just a brother of TCP/IP. Socket-based, it is based on IP sockets and uses datagrams and port numbers to communicate. It is connectionless, which means no handshaking, COVID safe and all, and then no buffering of datagrams. So it sends a command and forgets about it, okay? No buffering of datagrams at either end. But it is fast and is meant for this real-time communication between objects that want to communicate. But there is no guarantee of message delivery, and there is no guarantee of message order. So you might send two commands in one order, but the responses might come in some different order. So a programmer has to worry about those things when that kind of protocol is used. You saw an example of that just today. When one of them took the command to land, but the other one just ignored, and because the packet got lost in the communication. So that's the drawback of UDP/IP, but at the same time, it is also very fast. And that is the speed of the communication that matters more than these guarantees that you want. The guarantees can be built by the programmer, not the speed. All right, so in Ruby, if you had to kind of use a UDP example, this is the example I'm going to use throughout. Has nothing to do with drones, but just a way for you to know what UDP socket looks like. You have to require the socket library of Ruby. You set up the host and the port because that's how it communicates on that host to that port, and some message to be sent to that object. And then you create a new socket. You bind that socket to the host and the port, and you send the message across the socket. And then you wait for the data. Now, in this particular example, it's not threaded. As you can see, it is waiting for the data to come in because it's sending a message to itself. It's literally sending it to itself. So there is no chance of it getting lost because where it's going to go. And then if you print the data, that's the data that you see. come out of it. So prerequisite number 1 was trivially satisfied by Ruby. In case of concurrency, like I said, there are fibers, which is cooperative concurrency, which means the two fibers have to know, the programmer has to know that this fiber is going to give up control for this fiber to take it up. And so there is cooperative concurrency. In case of threads, there is preemptive concurrency, which means the programmer has no control when the thread will switch, which thread will get control. And then there is reactors. This is still experimental, I believe, in 3.0, but pretty soon it might become core part of the language. It's the actor-based parallel execution. So if there are multiple cores on your computer, then it will actually do things in parallel. So these were also trivially met for Ruby. And then coming to my slide that I wanted to show. So there is a library called Ruby OpenCV, which wraps the OpenCV C++ library for video streaming. My C++ is not that great. I tried very hard to compile it to bring it up to the current level. So it is Ruby 2.x and CV 2.4.13. It just stagnated at that point. It is on that, it's right there for last 8 years. And I wanted a more recent version. I tried getting it upgraded. I couldn't, so I gave up on the video streaming part of it. I couldn't even get OpenCV to run, just the raw OpenCV to run on my Mac, which is a more recent Mac. So this is not satisfied. We won't see a demo of video streaming of the drones from their camera. What about mruby? So mruby by default has only fibers. There's no threads in mruby. And for the socket, for the communication part, you have to compile mruby with the socket gem it's a core gem, so it comes with mruby, it comes with the core installation of mruby. And again, if it's not there in Ruby, it's unlikely for it to be in, if it's not there in Ruby, it's not unlikely to be in mruby. So as of today, I have not seen any attempt to make video processing, streaming possible in mruby. Not all of you are aware of mruby though, so a little slide on what mruby is. It's a lightweight implementation of Ruby, and that's my line of interest, my subject of interest. And the M stands for maybe embedded Ruby or modular Ruby or minimalistic Ruby. There are so many ways you can call or interpret that M. In terms of features, it's a proper subset of Ruby. Everything you can do in mruby can be done in Ruby, but not vice versa. But in terms of deployment architectures, it's the other way around. You can deploy mruby at more spots and in more environments than where you can deploy Ruby. The nice thing about mruby is that you can compile your code into a single executable, okay, with very little dependencies on the library of the operating system. And the use cases typically are for bare metal programming. There is no operating system available, not even a file system available. That's where you can do some bare metal programming using mruby. For memory constrained devices, which is my line of interest, I used to program these hardware point of sale systems where you swipe your card on, and then I was wanting to program those using mruby. I failed because mruby is still bulkier than what those devices need. But we have made a lot of progress since I tried it last, so it's probably possible now, and those devices also have become bigger in size. So the latest version of stable mruby 3.0 apparently can launch an app within 100 KB of RAM. And the devices that I had were requiring less than 64 KB of RAM, so I doubt that would have worked even now. But they are making progress. This is one of Matt's favorite projects, and you will see his commits almost daily coming into mruby. It's very active. And then, of course, game engines and things like this. So that's what mruby is all about. How do you do this in mruby then? Well, the only one line change is that there is no require. Why no require? Because it does not assume the existence of a file system. And requires files to exist. Require from where? So no require. And nothing else changes. Same code would work. If there is no require possible, how are you going to do it? Okay? So what you have to do here is you have to recompile the interpreter with that core gem. Okay? There is a build configuration script in mruby when you clone the project. And in that, there is this file called buildconfig/default.rb. If you just add this extra line saying, hey, I want you to be compiled with mruby and the socket library of mruby, that's how you would do it. When you get that into the build, and you clean up the previously compiled version if you had any by doing rake clean and then rake it. It will compile the interpreter with the socket layer built into it. Okay, makes sense? And then what you have to do is use that compiled version of mruby to run that example. So I haven't touched the example, I've removed the require and I've recompiled mruby. But what if I want to convert this program into a single executable that I can distribute, like a exe or a binary? That process is slightly convoluted. There are two ways to do it. You can either compile your program, that example.rb, into a bytecode by using mrbc command that gets compiled in the bin directory of mruby when you recompile it. And that bytecode can then be distributed to whoever has mruby installed on their system, and they won't see the original code, source code, because now they only see the bytecode. And then they have to use the -b option to run that example, and does the same thing. But what if you want to go further and say, I don't want the person to have mruby installed on that machine or that device, right? So that's where a little bit of C is required, and it's a two-step process. So what you have to do is you have to use mrbc, the same compiler, to generate what is known as a symbol table, okay? I won't go into the details of that, but it's a table that is a data structure that stores the bytecode, okay? And then you require, so you give a name to that symbol table that you want to use. There are some conventions, not rules, conventions that you have to follow, and use the same example .rb to emit a file called udpexample.c. It just takes the file name, removes the extension, and attaches .c to it. And that's the data structure that you will have to include. And then step number 2 is you have to write boilerplate code. It's available in many examples out there. You just pick one. I picked the simplest one that could fit on my slide here. As you can see, I did not care about handling errors and stuff, but that's obviously not production quality code. But what you have to do is you have to include that emitted file, and then you have to open as if opening the VM. These are standard steps of compiling any mrbc code, and then see that line, that the dotted line that goes down there, that uses the symbol table that you generated in that step 1. And then at that point, that C code that you see on the right-hand side is a regular C file. I just use my GCC compiler that I have on my Mac, use the includes directory to include the files that are needed, libraries that are needed, and compile it. And that emits the UDP example binary. That creates the binary file. And that's the binary file that you can then distribute to whosoever wants it. They don't have to have mruby on their system. You get a nice compact binary file, okay? So these are the steps to create a native, what we call bare metal binary. All right, so that's mruby. I had 3 focus areas for the purpose of this talk. One was to focus on Tello, one was to focus on actors and fibers and threads, and one was mruby. But I chose mruby because that's my favorite. Okay, well, show me the code. How did we get these things to fly? Are they still on? Oh, I should have turned them off. So one thing that I have noticed about these is the battery life. Even though the reported battery life is, 15 minutes of flight time. I've never gotten 15 minutes of flight time on one charge. I've only got about 5 minutes of flight time. So you have to be careful about these. I have an extra pair of batteries. So if we run out of batteries, that's not a problem. How much? So that's the time that I have left, right? Okay, so I have, on my GitHub, I've created a project for Tello, where I have written the same code that I will show you just now in Ruby and mruby and Crystal, which is a language that I'm playing with, and a friend of mine contributed in Elixir. Because remember those 3 prerequisites? Video is just optional, but those 2, any language that has those 2 should be able to drive these drones. So if you have any favorite language that is not on that list in that project, please submit a PR and I would be happy to merge it in. Today, we are going to only focus on the second GitHub project, which is, I curated my list of Ruby files for this conference. And the one that we saw running right now, just now, was hello.edu.rb. We'll go through that. And all of this started because of the gentleman called Tom Black. In one of the previous RubyConfs, he had a 5-minute lightning talk when he demoed these. And I got excited by what he showed us. He used the previous version of it, which could not be swarmed. So I worked with him, and we collaborated on coming up with the second version of the gem. My PR request is still pending, but I'm pretty sure he will, after he likes the code, the way I've written the code, he will merge it in. So if you go to that particular GitHub repo, you will get a gem that allows you to stand up a Tello server, a local Tello server, so you don't need the actual Tellos to be there, and you can test your client code against it, and all that kind of fun. He has put a lot of effort in it, so I'm very thankful towards Tom Black. All right, so that's the code that we are going to see today, and also modify. So I'm going to pop out of this and point you to Tom Black's repo. That's the Tello gem that I'm talking about. This is my repo, and this is the code that I have written for the conference. So please, and this is the project where I said, yeah, PRs will be appreciated. What I have to do now is I am on, okay, since I am not on the public Wi-Fi, I'm on this Wi-Fi, which is not connected to internet, I won't be able to drive through. So what I'm going to do is instead, I'm going to show you the code. The code that I want you all to see, this is not production quality code, this is just so that I can get it in as little, this is the hello world equivalent, so it's not at all how you should write code, okay? For example, let me see if I can pump this up. Can you all see this? So for the for those two drones that I have over here, this is hardwired for 2 drones and 2 drones only. I've used global variables, you shouldn't do that. There is no class, I've just used methods that send a command to the 2 drones and receive the responses coming back from those 2 drones. And I did all my work on Raspberry Pi, which has a camera attached to it. And so as soon as these drones take off, it starts the camera on and captures the video. That way, if things did not work, I would be able to show you the video and say, hey, look, this is how it worked. But thankfully, it worked. So this is completely optional. The if statements will take care of it not coming in the way if it's not a Raspberry Pi. And then all you have to do is start a thread, which will receive the response that you're going to get from the drones. Send the commands one by one. This is to set the Tello in command mode or in listen mode. When you talk to your kids, listen to me, listen. That's that mode. You go in the command mode, and then you check the battery level because there are certain gymnastics it can do only when the battery levels are above some values. For taking off, for takeoff and landing, you don't need much. So here you can see, I check the battery, I ask you to take off. We are going to do some of these things right now on the fly, and then land, and then mission accomplished, and close the sockets. Okay, so this is the code that I ran. I'm going to try it again, but this time I'm going to try to see if we do some more with them than just take up and land. I'm only hoping that there's enough battery for them to do this. Okay, so while they are booting, the boot sequence, what I'm going to try to do is flip them. Let's see if that works, okay? All right, so one of these drones will flip right, the other drone will flip left, they will go further apart and then land. Okay, that's all I'm going to do here. Let's give that a shot and see what happens. Okay, so do you see you know what? I should also expand the font size so you can see the running of the okay? Typically, when you reboot them, if no extra device has been attached, the IP addresses retain. So I'm hoping that the same 2 IP addresses are still valid. And let's see what happens. Are they all on, both? Saying yellow? Yeah, okay. Let's see. There you go. All right, I have 5 more minutes. Should we keep on going? All right, then let's do one more thing and try to do the flip and flip 2 flips, okay? 2 flips, same thing. All right, watch this. Now they're well behaved. And now they should come back together. If there are no errors on the console. This one did. That's the newer one. That's the older one. And it got an error. Do you all see the screen where the error is? Okay. Can somebody get that for me, please? Can we keep going? I have 4 more minutes. I will have question. I want to do only one more thing, and then we can switch over to question answers. Okay. All right. So this, what it is doing is going to rotate clockwise. One is going to rotate counterclockwise. The other one is going to rotate clockwise. And let's see if that works. Okay. So let me clear this. Can you all read the font? I mean, is this large enough? Okay. Return. All right. Here you go. Okay, okay. I still have juice. They should kick off. They should flip. There you go. Now they should turn, rotate. See? They rotated. And now they should land. There you go. Thank you very much. Thank you, thank you, thank you. That was it, guys. This is, they have been in their best behavior today. Questions. I have 3 minutes for questions. As you can see, it's very simple. Please submit PRs of the code in. Oh, I do want to do one more thing. If you do submit a PR, I would like for you to follow the model that my friend followed. So I'm going to switch over from this mode. Have to drop off, and I'm going to now connect to the Ruby, the public internet here. And if you notice, this is mine, right? Yeah, okay. So in my code base, as I said, you have Crystal, which is a language like Ruby, Elixir, mruby, Python, Ruby, whatnot. But my friend Craig submitted his PR just a few days ago, and that's the model I would like to follow. None of my code has that much of detail. He has given all the details in the README, how to install it, how to use it. That's awesome. I would love PRs to be like this thorough. Thank you very much. Yep. Yes, can we try that? Let's try that. So I'm going to, I have only 1 minute left, so I don't know how much. So I'm going to try it with the newer one, okay? It is possible. Good question. Thank you very much, because that does not bring out the power of the Tello gem. So here I'm going to go into my Tello gem folder. If you all can see it. Just to be on the safe side, I'm going to kind of, I think rake builds it. Yeah. Okay, so which was, oh. That's why. Okay, I'm not going to fight this. I have the Tello gem, I believe the edu gem also installed on mine. So let's see if that works. So this is like a interactive mode, like IRB of Tello. And now, sorry guys. So I check out main. Does it generate in Tello? Dang it! I should have thought of this question beforehand and be prepared with it. Oh, why is it saying the permission error? Anyway, so the Tello gem allows you to run it in an interactive mode, like your question you were asking, Greg. It is possible to send it command by command, but then you have to remember that the first command you have to issue is the command, and then start with the takeoff, flip, land, and stuff like that. I'm almost out of time here, so if you want, we can try it outside somewhere. You know, let's capture a little niche and play around with it, and you all can come and join. And if you install the gem, we will be able to control two computers to control one gem and multiple controllers controlling multiple of these tellers and stuff like that. But yeah, it is possible to answer your question, Greg. Thank you again. Thank you all.